That's what you were supposed to do at home and ask for the memo. So we had exercises on isosceles triangles. There was exercises on straight line, revolution, parallel lines. There was that nice one that had all those letters in it in exercise 14. I'll show you now. So hold on. Exercise 14 was this nice one where all the things were being asked. Exercise 15 is what we did last time I saw you. And I said these were very important. Any questions? If you don't ask, I don't know. It's a pigeon. We have a pigeon nest over there. Outside in the gutter somewhere. I don't know exactly where, but they are pigeons. No questions, grade 8s? You sure? 100% sure no questions? Or first check the memo and then ask again tomorrow. Okay. Then we are today going to recap Pythagoras, because Pythagoras is being asked in your test. Then from tomorrow is not examinable in this test. So we're starting similarity and congruency tomorrow, but it is not in the test. What we are doing today is in the test. Okay, we are doing Pythagoras. So you can write today's date. It is the 7th of September. Yes. Pardon? Geometry? Just Pythagoras, not even perimeter. Just geometry and Pythagoras, that's it. No perimeter, no area. No total surface area, no volume. Just Pythagoras. And all 9 reasons of your geometry. Yes, I was about to say that. You do need to know your types of triangles. You do need to know your types of angles. And you do need to know how to name angles with 3 letters. So I'm going to say all of that again. Naming angles with 3 letters. Classifying the angles as acute, obtuse, straight, right, and reflex and revolution. Your types of triangles. What do you look for the different types of triangles? And your 9 reasons for geometry, and then Pythagoras. It is on OneDrive. I also sent it on the group twice. Does anyone need me to repeat any of that? Are you sure? Okay, I was looking for my notes from last week, so I give you the exact same thing. But I do feel a little bit lost right now. It's grade 9, grade 9, grade 9. There we go. Where did my Pythagoras go? Okay, well, we'll just do it again because I can't find it. Okay, Pythagoras recap. I took pictures of it this morning, so I should have it on my phone. There we go. Okay, Pythagoras is a theorem that we use in mathematics, and the words of the theorem are the following. The long side squared, let's write squared in words. The long side squared is equal to the sum of the squared short sides in a right angled triangle. So the long side squared is equal to the sum of the squared short sides in a right angled triangle. So there's some key points that we need to know here. Firstly, that it must be a right angled triangle. If it's no right angle in there, we can't use Pythagoras. Must be right angled triangle. The other thing that we need to note is, how do we find the long side? My long side is called the hypotenuse, and it is always opposite the 90 degree. Opposite 90 degrees. And the rest we can actually put into a formula. Waiting for all of you to finish writing. Okay, let's have a look at that formula. So the formula is always my long side squared. That's what it says. So long side squared is equal to the sum. So I'm going to be adding things. Okay. Squared short sides. So there will always be two shorter sides. We're just going to square them and add them together. Now when I give you a triangle, we actually have to call it by the side names. A, B, C, D, that kind of thing. And whenever we use Pythagoras, we need to give the reason, just like we did with all our other geometry. And you can either say the full word Pythagoras or Pythag is fine. So we'll work through a basic example together. Just to recap how to name and all of those kinds of things. Okay, doesn't look like anyone's rewriting too much. I'm just going to zoom out a little bit so you can see our triangle. So I give you a triangle and I tell you to solve for x. Currently, can I do anything? What can I do? How do you know that? I can't assume anything.
Because the 4 and the 3 on the side for AC, AB, the side of the angle, so and the hypotenuse is S.
But I don't know that there's a 90 degree, Amita. What did you want to say? There's no 90 degree shown. I don't tell you that it's 90 degree. It's not in the diagram. So could we technically be able to use Pythagoras if we don't know that it's a right angle triangle? No. So currently I can't do anything. It's only after I show you that there's a 90 degree that we can now do Pythagoras. And we have caught out plenty grade 8s in the past because they didn't look for the 90 degree. So, my long side. What is the name of my long side? Hypotenuse. And if I have triangle ABC using 2 letters, which is my hypotenuse? CB or BC, doesn't matter which order, right? So I would write BC squared. So what are my short sides? AB and or AC, here we go. Doesn't matter which one I write first. Doesn't matter the order of the letters as long as it's the correct letters. So that was my hypotenuse, that was my short side, that was my short side, and immediately I'm also writing Pythag. Then substitute for me. What can I write for BC? What is the value of AB and what is the value of AC? Write it down for me, please. Okay, so BC, as Kenan was trying to tell us, is my x. AB first. 4 squared is equal to? So I have x squared equals to 25. Then we must square root. And we must always square root both sides. So my x is equal to 5. So we did this in term 2. I can't remember if we started in term 1. I don't think so. And you should have also recapped it with Mr. White at some point. Yes. Yes. But you still need to know how to calculate it. It's called a Pythagorean triplet. Because if it's 3 and a 4, then the other one is 5. It'll always be one of those. Or 4 and 5, and the other one is 3. It's a triplet of numbers that will always work out. That's the easy one. I'm going to go one more step difficult, and then even more difficult after that. Okay, I want you to do the next one. Anyone still busy writing? Okay, let's look at the next one. Drawing a right angle triangle, and I'm calling it DEF. And then this one, I'm telling you it's 90 degrees, so immediately you can do Pythagoras. D, E, and F. This one is 12, 13, and my X is over there. So using two letters, which side is my long side? DF. Because my rule tells me that it must always be the long side squared is equal to shorter sides squared. Then it'll be DE squared plus FE squared or EF squared, and I would write immediately Pythag. So I haven't even looked at the values yet. I started with my theorem. Long side squared is equal to short side squared plus short side squared Pythag. What is the value of DF? DF, 13. DE, FE. So you see how my x squared is not always by itself in the beginning, because it's not always the long side that's missing. So you always need to start with long side squared equals to short side squared plus short side squared, and then substitute in all the different values. 13 squared is equal to? Ooh, timetables are bad. We can do it that way, but I want to practice your timetables. 13 squared.
169.
12 squared.
140.
I want x squared by itself. Is it currently by itself? What should not be there?
The 169.
The 169 is by itself. I want x squared by itself. Dylan? And then we're minusing. So 144 is plus, I take it over, becomes minus 144 equals to x squared. 169 minus 144 is equal to? 25. So x squared is equal to 25. But I only want one single x. We're going to square root both sides. So the first one was your easiest one. The second one is one step more difficult, and we're going to do another one which is even more difficult. So I'm just going to leave that on the board while I start drawing the next one. Is this all coming back to you, grade 8s? Hopefully you are masters at Pythagoras already. And we'll see if that is true in our next example. Okay, anyone still busy with that? Shouldn't be. Okay, there's my next triangle. So draw the triangle first for me. My first question is, name all right-angled triangles that you can see. So a triangle name has 3 letters. Write it down onto your book. Triangle name has 3 letters. For example, triangle ACD is the name of a triangle. Now, I only want ones that are right-angled. Okay, so how many right-angled triangles do you see? Dylan? 2. A small one called, which is a small one? ABC. Someone else can identify the second right-angled triangle. Rio? Lorna? Keelan, I wasn't asking you. Can you stop shouting out, please? You've been doing it the whole lesson. Give other people a chance. I can see that you're doing this very well, and I love that you know what you're doing, but other people also need a chance. Lorna was busy. A, B, D. Fantastic. There. A, B, D. Big triangle. Okay? So now so that's our 2 triangles, A, B, C, and A, B, D. Now my next question to you is, out of those 2 triangles, which has more information? Alita? A, B, C. Look, 1 missing side, given, given. 2 sides given. Let's look at the big one. Missing, missing, given. So A, B, C is more information. So which one are we going to work out first? A, B, C. So work out A, B, C for me, please, using Pythagoras. Yes.
Instead of A, instead of A, B, C, we have a C, O, B, or
You want to swap the two letters around? Yes. So it can be A, B, or B, A. Okay, should be just about finished finding AB. Okay, so in my triangle ABC, that's what I'm dealing with. Which side is my hypotenuse? Name it with two letters, Keenan. AC. Then my two short sides would be AB squared and BC squared. What is my reason? Pythag. Now I'm going to substitute. Do I have a number for AC, Rio? A number for AC? So AC. 10, there we go. Liam, AB? AB.
Oh, sorry.
Almost caught you out there. BC is 8 squared. So now you can do it, grade 10. 8, there's no problem whatsoever for you to take the 8 over immediately and minus it like this. I don't mind, okay? You can do that, I don't mind. But that would still work out to 100 minus 64, which is equal to what? AB squared is equal to 36, so what's my last step? And the square root, not Keenan. 36 square root is? There we go. So AB is equal to 6 units. So you should have just marked yours. And if I have AB now, can I now solve triangle ABD? Now I can. So I have in triangle ABD, which side is my hypotenuse? Yes, Lorna. AD, fantastic. And then AB is the short side and BD is the short side. What is the full value of BD? Yes, Dylan. Which is equal to? 15. There we go. So let's do it. Long side squared. So I'm just writing here in triangle ABD. My long side, as Lorna told us, was AD squared. And my short sides were AB squared and BD squared. And immediately I'm using Pythagoras. So I am writing Pythag again. Every time we have a new triangle and we use Pythagoras, we write it again. So AD squared is my x. AB we just calculated as 6. And BD I've added together as 15 squared. 6 squared is 36. 15 squared is 225. Go further for me. And yes, you will get a funky answer. So finish that sum for me, please. Like I said, you will get a funky answer. So 36 plus 225. I think so. 261. Square rooting both sides. Your calculator is going to give you a freaky answer of the following. We call it third form. 3 square root 29. That just means it's not a perfect square. That's all it means, but that is still my answer. Yes, Erin? Yes, you may. So that is, we leave it in third form. Third form means with the square root. If I had asked you for a decimal, you would just press your SD button and give me your decimal. 16,16 units. It depends. If the question says leave it in third form, then you have to. But if it doesn't say, then I have to mark both. So a lot of the times we do say leave in third form. Then you have to leave it with the square root. But if it doesn't say anything, then you can leave it in either one. Okay, any other questions? Yes, Lorna. Yes, geometry is always with calculators. And since it's a geometry paper, you will allow your calculator. Okay, I'm going to do one more Pythagoras. And then the bell will probably ring. And then tomorrow we're going to start off with new, it's still geometry, but not in this test. Okay, so I'm going to do it as an exercise, which means I'm only giving you the question. You need to practice by answering. Okay. So you may or may have not seen the answer, but you still need to be able to calculate. I want you to calculate the value of x. Now my question to you is, if BCD is a right angle triangle, is ABC a right angle triangle? Why, Dylan?
Because the line of the thing is straight.
There we go, angles on a straight line. So that means the other triangle is also a right angle triangle. So find x for me, please. So they are both 90 degrees. Find x, you'll probably need to do more than one step. Okay, we're solving for x in this diagram. Only giving you 2 more minutes so that we can mark it before the bell rings.